Okay, before going into today's class, first we will explain what is a relation. Already you have learnt before classes, not last class you have learnt what is a relation. Suppose a set, a set P contains 2, 4 and a Q is a set that contains 10, 20, 35. Okay, these two sets, P set 2, 4, Q set 10, 20, 35. And we say the relation R is a relation that contains the ordered pair 6, y for every x belongs to the first set P and y belongs to the second set Q. So we say this R is a relation which contains the ordered pair 6, y that should satisfy this conditions of the given relation. Okay, for that you have to get this ordered pair, you have to find the Cartesian form of P cross Q. What is the Cartesian form? This pair with every images, pair it. Okay, for 2 find the pair images for 2, 2, 10, 2, 20, 2, 35. Same way for 4, right? 4, 10, 4, 20, 4, 30, 5. So these are the possible outcomes. What you say? The cross product, the elements of the P cross Q. In this, whatever, see, suppose R dash is a relation that contains x, y for every y such that this y is a multiple of x. Okay, where x belongs to first set what P, yeah, and y belongs to the second set Q. So here the condition is given. The relation condition is given. What? That y should be a multiple of x. Then what is it multiple of x? See that P contains, see this P set elements is listed as x and Q set elements is listed as y. Okay, here multiples, y should be a multiple of x. If you take x, here x is 2 and y should be, y is 10 and x is 2, y is 20. That is a multiples of 2. Can you take this x as 2, y as 35? Can we take this 35? It is a multiple of 2? No. So 2, 10, 2, 20 will form the relation. Same way, when x is 4, your y is 10 and then x is 4, y is 20. That also forms the multiples of x. The y is a multiple of x. So for 4 this 10 will not come. No, y should be a multiple of x. For 4, 10 will not come. Why? Because this 4 multiples is not 10. So this 10 you should not take. So 4, 20 you can take. So this is how the relation is specified in the question. So this is 2, 10, 2, 20, 4, 20 is your R dash now. So this is a relations given, condition is given. It should be a ordered pair. The second set element should be the multiple of the first set element. So in this 2, 10, 2, 20, 2, 35, 4, 10, 4, 20, 4, 35, this 35 is not going to exist. It is not a multiple of first set element. So my first set elements contains 2 and 4, right? Now if you take 2 and 10, it's 2's multiple. The 10 is a 2's multiple, so you can take that. And 2, 20, this 20 is a multiple of 2, that also you can take. And then here 4, 10, this will not come, 2, 35 will not come. 35 is not multiple of 2. Then 10, 4, 10 is not the multiple of 4, so this you cannot take. Then 24, that you can take, 20 is a multiple of 4. This again 35, 44, that is also not going to be the multiples of the first set value. So what is the relation here? Elements you got is 2, 10, 2, 20 and then 4, 20. So these first set numbers are called the domain and the second set elements is called the range. So your domain element will be 2, 4 and range elements will be 10, 20. Only the element that has the images, that alone we will say it is a range. So second elements we will say it is range only when the only paired elements alone we will say. See here, I will do it in the circle form. See x, your p set elements, that is x, and here the q set elements, that is y. We will say this 2, 4, the p set elements as domain, and the q set elements, what you have, 10, 20 and 35. This q is total, we will call it as codomain. 10, 20 and 30, 35. So this q set elements is codomain, p set elements is domain. Only if paired elements, we will say it is a range. So 2 is paired with 10 and 2 is paired with 20 and 4 is again paired with 20. So each element of this p set has images over the q. For those elements alone, we will say it is a range. The first set elements is domain and the second set elements forms the range. The domain elements has images over the codomain. So the related elements alone, we will call it as range elements. Is it clear now what is the domain, range and codomain? So in the relations, the first set elements will form the domain, the second set elements that forms the codomain, the imaged elements, the paired elements, domain images formed under the Q, that elements alone will come under the range. 2's image is 10, again 4's image is 20, that alone will come under the range. The unpaired elements in this Q, that comes under the codomain, that forms the codomain. Is it clear? So the whole set Q will come under codomain, whole set P comes under domain. So every element of this P will be paired, one or the other way it will be paired. So this forms the domain, P forms, first set element forms the domain, second set element will form the codomain, and the paired elements, that alone forms the range. The unpaired, this 35, that comes under the codomain. So this forms the codomain, and here P set elements will form the domain, and the paired one will form the range. Images, also have the elements, images of P and Q will form the range. Now we understand what is the relation domain, codomain, what are the images, is it not? Now what is, next class we will say what is a function.